Hello everyone, welcome to the course on operating systems. In this session, we are going to discuss about memory allocation in operating systems. The approach of allocating the required memory to each process by efficiently utilizing the memory space is called as memory allocation. That means, as we know, whenever a process has to be executed, it has to be loaded into the main memory. So, certain amount of memory has to be allocated for each of the process that has to be executed by the CPU. So, we have different approaches for memory allocation. One is contiguous memory allocation and the other one is non-contiguous memory allocation. In case of contiguous memory allocation, each process will be allocated contiguous set of memory locations. That means each process will be allocated adjacent set of memory locations. And again, contiguous memory allocation can be implemented either by using fixed sized partitions and by using variable sized partitions. On the other hand, we have a non-contiguous memory allocation where each process is not allocated a contiguous set of memory locations. Instead, the memory of each process is scattered across the different parts of the main memory. We have two different techniques for implementing non-contiguous memory allocation. One is called as paging and the other one is called as segmentation. In this session, we are going to focus on the contiguous memory allocation. In contiguous memory allocation, a process is given a single block of contiguous memory locations to execute. The entire process resides in one contiguous section of the RAM. And the advantages of this approach is this method is relatively easy to implement and it simplifies memory addressing because the entire process is stored in one contiguous block of main memory. That means whenever a process has to be executed, all the instructions are available at one single block of main memory. That is why it reduces the overhead of looking for the other instructions of the program if at all it is scattered. So that is eliminated in case of contiguous memory allocation because all the instructions of the program are stored in one single block of main memory. Let us see the implementation by using fixed sized partitions for contiguous memory allocation. If you look at the main memory, operating system is stored in the main memory and the remaining part of the main memory, which is called as the user area, is divided into fixed sized partitions. In this example, we are considering fixed sized partition of 5 MB of each. Now, let us see, there are 5 different processes which are of having capacity. Process 1 is of 1 MB, process 2 is of 2 MB size, process 3 is of 3 MB size, process 4 MB size and process 5 MB size. So these are the processes that are to be executed by the CPU. So in such a case, these processes have to be allocated memory in the main memory region. So if we allocate the first block of 5 MB to the process 1, so which requires only 1 MB of space, there is another 4 MB of space that is being wasted. Here you can see the memory wastage after storing process 1 is 4 MB. And similarly, by storing process 2 in the second partition, which is of only 2 MB capacity, but here the partition size is of 5 MB. So the remaining space that is wasted is 3 MB. So another 3 MB after storing process 2. And similarly, process 3 will be stored in the third block. Process 3 is of size 3 MB and the remaining 2 MB of space is being wasted here. And there is again another 5 MB of space for storing process 5. Anyway, process 5 is also 5 MB of capacity. So there is no wastage of memory when we are storing process 5. So putting together the memory wasted after storing process 1, process 2, process 3 and process 4, is coming around 10 MB of space. So this is called as internal fragmentation. Internal fragmentation means the wastage of memory whenever processes are allocated contiguous set of memory locations by using fixed sized partitions. Because here we can see the wastage of memory in each partition. That is why it is called as internal fragmentation. So it divides the memory into fixed sized partitions and allocates the process to these partitions. And this method is relatively simple to implement because we are simply partitioning the main memory into equal sized blocks. And the drawbacks of this method are, if you look at the number of partitions, there are only five partitions. So we can store a maximum of 5 processes at any given point of time. So we will not be able to accommodate excess number of processes if we are using contiguous memory allocation with fixed sized partitions. And one more drawback is if the size of the process is greater than the size of the partition, then also we will not be able to execute the process. For example, let us consider process 6, which is of size 6 MB. In such a case, we will not be allocate any partition to process 6 because the size of the process 6, which is 6 MB, is more than the size of the partition. And one more drawback is it leads to internal fragmentation. So these are the drawbacks of fixed sized partitions. One is it results in internal fragmentation. Here the size of the process should not be greater than the size of the partition. That is second disadvantage. And one more is you cannot have more number of processes as compared to the number of partitions that are available in the main memory. Now let us look at contiguous memory allocation with variable sized partitions. In this case, memory is divided into variable sized partitions based on process requirements. For example, let us consider the main memory where the operating system is being loaded and it is occupying around 8 MB of space, and the remaining user area is 56 MB. That means the RAM size is of 64 MB. Now we are considering 3 different processes which are of capacity. P1 is 20 MB, P2 is 14 MB, P3 is 18 MB. Now, whenever process 1 has to be allocated memory by using variable sized partitions, we simply allocate the user space that is available after the operating system is loaded. That 20 MB will be allocated for P1, process P1 out of 56 MB, and we are still left with 36 MB, and process 2 will be allocated another 14 MB, and process 3 will be allocated another 18 MB of space. So putting together, it is coming up to 20 plus 14, 34, 34 plus 18, 52 MB is occupied by all the 3 processes P1, P2 and P3. And the remaining 4 MB space is still left. So this is called as a hole. Hole is the available space in the main memory which is not allocated to any other process is called as a hole. Now let us consider process P2 has completed its execution. Then the memory that is allocated to process 2 will be deallocated. That means process 2 will be removed from the main memory, creating another whole space of 14 MB. So putting together, we have a total of 18 MB of space, which is still available for allocating to the new processes. And at this point, let us consider another process P4, which is of 12 MB has arrived. So out of these 2 holes, only this particular hole of size 14 MB can accommodate the process P4, which is of 12 MB, because we are considering contiguous memory allocation. That means the memory to the process has to be allocated in a contiguous manner. So process P4 will be allocated this particular region of memory, which is of size 12 MB. And out of 14, we have allocated 12 MB and the remaining 2 MB of hole is again created. Now the whole size is now 2 MB plus 4 MB, which is 6 MB now. And remember, these are not available as contiguous set of memory locations. They are scattered in the main memory. And now let us consider process P2 has completed its execution. So leaving a hole of 20 MB. So again at this point, process P5, which is of size 10 MB, has arrived for execution. In such a case, we have to allocate memory for process P5. So which is of size 10 MB. So we have 3 different holes. One is 20 MB, one is 2 MB, and the other one is 4 MB. So out of these 4, 2, and 20, only this particular hole can accommodate the process P5. So we will be allocating 10 MB for process P5. Let us say process P5 is of 14 MB size. So in such a case, P5 will be allocated 14 MB and the remaining hole size will be 6 MB. So here we are left with a total hole size of 6 plus 2, 8, 8 plus 4, 12 MB of hole space is still left. But they are scattered across different parts of the main memory. Now at this point, assume that another process P6, which is of size 10 MB, has arrived. Now observe the scenario where we have the total hole size is of 12 MB, but we have only 10 MB. We have to allocate memory for 10 MB process, but this 10 MB is not available as one contiguous set of memory locations. That is why we will not be able to allocate memory for process P6. So this is called as external fragmentation. So the memory that is being wasted and the block of memory is available in between the partitions, in between the allocated memory regions for the process. We call it as external fragmentation. So this external fragmentation can be overcome by using a process called as compaction, wherein all the process will be relocated in order to create a bigger whole. So in this example, the process P5, in between process P5 and P4, there is a hole. So simply move the process P4 upwards, and again in between process P4 and P3, there is a hole. So simply move the process P3 upwards. Likewise, if we move all the process, that means if we relocate all the process, we have contiguous blocks of memory allocated to P5, P4 and P3. Now all these memory locations which are available as holes are collected together to form relatively larger block of memory. So that is this technique is called as compaction. So when we apply compaction, we are able to find available block of memory in the form of a hole which is of size 12 MB. So now our process P6, which is of size 10 MB, can be accommodated into the hole of size 12 MB. So the problem of external fragmentation can be solved by using a technique called as compaction, and compaction involves the overhead in terms of the time and processing power required for memory movement. So if you observe, here we are relocating all the processes. That means we are moving all the process. So which is consuming more number of computer resources, and it is also time consuming. So this though compaction is a solution for overcoming the external fragmentation, it is having the drawbacks of usage of more number of resources, and it is also time consuming. So in this session, we have discussed about the different memory allocation techniques, including contiguous memory allocation and non-contiguous memory allocation. And specifically, we have discussed about the contiguous memory allocation techniques, which include contiguous memory allocation with fixed sized partitions and contiguous memory allocation with variable sized partitions. And contiguous memory allocation with fixed sized partitions results in internal fragmentation, and contiguous memory allocation with variable sized partitions result in external fragmentation, and this external fragmentation can be eliminated by using a technique called as compaction, but the technique called as compaction is relatively more time consuming and it results in wastage of resources. So in the next session, we'll be discussing about the non-contiguous memory allocation techniques, which include paging and segmentation. Thank you.